Welcome to digital lessons. In this session, today we will learn about classification of elements and periodic table. First, we will study evolution of periodic table. Children, have you ever visited medical shop for medicines? Yes. How the shopkeeper will arrange the medicines? Yes, in alphabetical order in small boxes. You are right. The shopkeeper will arrange medicines in alphabetical order in order to take them very easily and to give it to you. Now, there are many elements for us. For them we need a proper classification. Have you ever visited a supermarket? How the items are arranged there? One corner you will find all biscuits at one place, vegetables at one place, fruits at one place, like that the order we will see. Now, in order to classify elements also we will follow same pattern. Now, it is the modern periodic table which we are finding nowadays, but there is lot history behind it. Now, we will discuss that history and how we got the evolution of this periodic table. This is a modern periodic table. Now, we use many type of items in our day to day life. Do you know what are the materials used to make these items? Do you know what kind of materials the utensils in our kitchen are made up of? Now, let us see, we will find many items in our kitchen. What are these? Yes, these are aluminum vessels, these are steel made up of iron, nickel, chromium, it is an alloy. It is a bucket made up of brass, it is an alloy of copper and zinc, it is copper. We will find these sort of vessels in our kitchen. Do you know what is it? Yes, it is a bicycle. What is the material used in making the bicycle? Yes, iron, plastic and rubber for tires and tubes. What is this? Yes, it is a desktop computer and laptop. Do you know what is the material used in making the computer? Yes, in our 8th class we studied bakelite, it is a plastic, it is a synthetic fiber. The items such as utensils, bicycle, computer, pens and many more items are made up of different types of materials. These materials are available in earth, in air, in water, in the form of elements. We get elements from salts and minerals, these are salts and minerals. Now, elements also exist in solid state, liquid state and gaseous form. Now, what are these? It is universe. Now, our all planets are there in our solar system. We get any elements from other planets also. How do we get the elements from other planets? We are not visiting there and collecting. Yes, in the form of meteorites. When they hit the surface of earth, our scientists will collect these materials. Some elements are collected from air, water and different planets in the universe. Several new substances are formed by mixing, burning and separating techniques of various elements. Children, do you know our human body is built by using carbon, hydrogen, oxygen and water. Now, do you know what is the composition of water? Yes, it is H2O. H stands for hydrogen and O for oxygen. The hydrogen and oxygen in water are also elements. What is an element? Any substance that cannot be decomposed into further simple substances by a physical or chemical change is called an element. It is according to Robert Boyle. Now, he is the scientist Robert Boyle. During the time of Robert Boyle, only 13 elements were known. That means, by the year 1661, We know only 13 elements. Who is he? Yes, he is 𝗧𝗧𝗧. During the time of 𝗧𝗧𝗧, only another 11 elements were discovered. That means, in total at the time of Robert Boyle there were 13 elements, at the time of 𝗧𝗧𝗧 there are 11 elements, in total 24 elements were discovered by the end of 18th century. Now, by 1865 about 63 elements were known. By 1940 a total 91 elements from natural sources and another 17 elements synthetically were obtained. Till now scientists discovered more than 118 elements. Some are radioactive elements. As the number of elements increased, it became very difficult for the scientists to find the relationship between them. They established the relationship between their physical and chemical properties and categorized them into some groups. Now, this is evolution of periodic table. Now, it became necessary to classify them systematically. Now, all elements should be classified. Therefore, we should find some criteria to find the chemical behavior of an element. We can remember them very easily along with their properties. How the elements are classified are arranged in systematic manner. Now, all chemists discovered the elements and their compounds. Now, some elements were fused and formed compounds. By that they can establish the relationship between elements. New elements were discovered. With the new elements we can make several new compounds. Now, the primary criteria in the formulation and classification of elements are their atomic numbers and atomic masses. They were used to arrange the elements and their compounds scientifically. Now, what is atomic number? Children, you might have learned this concept in your 9th class. What is atomic number? The number of positive charges or protons in the nucleus of an atom of a given element is called atomic number. It is denoted by the symbol capital Z. How the subatomic particles are arranged inside the atom? Now, we will take the example of hydrogen and we will discuss this one. Now, it is the nucleus of hydrogen atom, one proton, one neutron and one electron is revolving around the hydrogen atom. Now, what is the atomic number of hydrogen? 1. Why? Because we are having only one proton. Now, it is the atomic number of hydrogen, it means number of positive charges or protons in the nucleus of hydrogen atom. You see the nucleus, how many protons are there inside the nucleus? Only one proton. Therefore, atomic number of hydrogen is 1. Then what is meant by atomic mass? The mass number is the total number of protons and neutrons together known as nucleus in an atomic nucleus. Children, mass number is nothing but the sum of total protons and neutrons which are inside the nucleus. Now, let us watch a small video about this atomic mass number. We will take the example of same hydrogen atom. Now, it is the nucleus of hydrogen atom, one proton, one neutron and one electron is revolving around it. Now, inside the nucleus what are present? Protons and neutrons. Now, what is their sum? Their sum is nothing but number of protons and neutrons inside the hydrogen atom. It is the mass number. Let us observe once again, inside the nucleus one proton and one neutron. The atomic mass of hydrogen is the total number of protons and neutrons in the nucleus of hydrogen atom, that is A equal to P plus N, number of protons plus number of neutrons. Now, who are the main scientists behind the classification of elements? Now, let us recall their names. The main scientists who classified the elements are John Wolfgang Dabonir, John Newlands, Dmitry Ivanovich Mendeleev, H.J. Moseley. These are the 4 scientists who are behind the evolution of new periodic table. How 𝗳𝗏𝗍 classified the elements? 𝗳𝗏𝗍's law of traits. Now, 𝗳𝗏𝗍 is a German chemist. He noted the group of 3 elements with similar chemical properties and call each group as a triad. That means, he named a group called triad. In that 3 elements are there. 𝗳𝗏𝗍 took the 3 elements with similar properties at a time and arranged them in ascending order of their atomic weights. That means, he arranged the in a trait, he arranged the atomic weights of elements in the ascending order. That means, from element of lower atomic weight to higher atomic weight. According to 𝗳𝗏𝗍's law of triads, the atomic weight of the middle element is the average of atomic weights of the first and third elements. It means, always in 𝗳𝗏𝗍's law of triads, atomic weight of the middle element is always the average of first and third element. Now, let us see here atomic weights of 3 elements I have given. It is lithium whose atomic weight is 7, potassium whose atomic weight is 39. Now, it is the first element in 𝗳𝗏𝗍 triad and potassium is the third element. Now, what is the average value? Average means we have to add the total atomic weights 7 plus 39, it is equal to 46. Average means divided by 2, 46 divided by 2, it is nothing but 23. It is nothing but the atomic number of sodium. Now, you see the atomic weight of middle element sodium is exactly same as the average atomic weights of lithium and potassium. That means, according to 𝗳𝗏𝗍's law of triad, the atomic weight of the middle element is the average of the atomic weights of the first and third elements. Now, we will go for second of 𝗳𝗏𝗍 triad. Calcium whose atomic weight is 40, barium whose atomic weight is 137 and some of their atomic weights and the average value is here 87.5. Now, let us see the atomic weight of middle most element, that is strontium, is 87.5, that is nothing but 𝗳𝗏𝗍's law of triads. The atomic weight of the middle element in a trait is the average of the first element and third element, it is also matching. We will go for third trait, chlorine whose atomic weight is 35.5, iodine 127. The average value of atomic weights is nothing but 81.25. Now, the element bromine whose atomic weight is 80. Now, here we are not matching this 80 with 81.25. Why? Because at the time of 𝗳𝗏𝗍 there were no spectrometers to calculate the atomic weight correctly. Nowadays, we are getting modern spectrometers by which we can get the exact weight. That is why this law is not applicable for some elements such as bromine. We will study it under limitations. Fourth trait, sulfur whose atomic weight is 32, tellurium whose atomic weight is 125. The average atomic value of this one will be 78.5, which is almost matching the atomic weight of selenium. It is the middle most element. Now, we will go for fifth trait, manganese whose atomic weight is 55, iron whose atomic weight is 56 and the average value of atomic weights is 55.5 and the middle most element is chromium whose atomic weight is 52. It is also not matching, it is also we will study under limitations. Now, according to 𝗳𝗏𝗍 law of triads, the atomic weight of the middle element is the average atomic weights of the first and third elements. Now, limitations of 𝗹-𝗫𝗏's law of trades. All the known elements at that time could not be arranged in the form of trades. It is the major disadvantage in 𝗹-𝗫𝗏's triads. At that time there were many elements, but all we could not accommodate in triads. Now, the law is failed for very low mass or for very high mass elements. That means, this law is not applicable for the elements having higher atomic weight and also lower atomic weight. In case of fluorine, chlorine, bromine, the atomic weight of chlorine is not an arithmetic mean of atomic weights of fluorine and bromine. We have studied under limitations. Now, here bromine value is not matching with the average values of the fluorine and chlorine. Now, let us see here chlorine and iodine is not having the average value is not same as the weight of the bromine. It is we are getting 81.25, but in the case of bromine we are getting only 80. Therefore, such limitations we observed later on. Now, we will study Lawrence Law of Octaves. Now, he is Newland, he is a British chemist. He found that when elements were arranged in the ascending order of their atomic weights, they appeared to fall in 7 groups. According to Newlands, he arranged the elements into 7 groups and he found that every 8th element is the repetition of the first element. That means, the 8th element is having the same chemical and physical properties of first element. Each group contained elements with similar chemical properties. According to the law of octaves, every 8th element resembles the properties of the first element. Newlands attempted to link the periodicity of chemical properties of elements with the periodicity found in the music. Now, children, have you listened in our Indian system of music? We are having the raga like sa re ga ma pa da ni. Now, there are 7 notes here sa, re, ga, ma, pa, da, ni. After that, we are again repeating sa, sa re ga ma pa da ni sa, like that. Now, here sa, this note also resembles that every 8th element is the having the same chemical and physical properties as the first element. Now, in Indian system of music, we are having musical tone like sa re ga ma pa da ni sa. Now, in the West, we use the notation do re ma fa sol la ti. Here also this do will repeat after the 7th sound, again do will come. Therefore, in Newland's law of octaves, we will find with our traditional music system, the relationship is there. In the same way, every 8th element is having the same properties. Here in the music system also these notes are repeating. Naturally, there must be some repetition of notes. Every 8th note is similar to the first one and it is the first note of the next scale. Now, children, it is the periodic table given by Newlands. Here we are finding 7 groups. We will see 1, 2, 3, 4, 5, 6, these are groups. Now, elements are arranged in the ascending order of their atomic weights. Now, the atomic weights in a group is also continuously increasing in order: hydrogen, lithium, carbon, nitrogen, oxygen, like that. Here fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, like this in every group we are finding that atomic weight is increasing order, that is ascending order. There are 7 groups in his periodic table. Based on the chemical properties, Newland divided the elements into 7 groups. Now, you see first group, second group, third group, fourth group, fifth group, sixth group, 7 groups. Like that he arranged the elements into 7 groups. Now, based on the chemical properties of elements, Newland classified the elements into 7 groups. He stated that every 8th element resembles the chemical properties of first elements. You see, hydrogen is having same properties of fluorine. Next, it is having the same properties of chlorine, like that it is resembling. Next group, we are having the same properties for lithium and sodium, and next same properties for carbon and silicon, same properties for nitrogen and phosphorus, same chemical properties for oxygen and sulfur. Like this, every first element, every 8th element is having the same chemical properties as that of first element in his periodic table. According to law of octaves, every 8th element resembles the properties of first element. Now, limitations of Newland's law of octaves. Now, there are some instances in his periodic table that the elements are arranged in same slot, not one element, he placed 2 elements in the slot. Now, here you see in his periodic table there is some space for the elements. Now, here hydrogen, fluorine, chlorine, only one element is incorporated, but in this 4th column you observe that cobalt and nickel placed in the same column. Like that we will find another instance, cerium and lanthanum, next instance, next rhodium and ruthenium, next barium and vanadium, next platinum and iridium. Now, all these are the instances where he placed 2 elements in single slot. Now, it is not applicable. Now, here you notice certain elements are totally dissimilar in their chemical properties were kept in same group. Now, you see, now he arranged cobalt, nickel and platinum, palladium are having some chemical properties, now which are not similar equivalent to fluorine, chlorine and iodine, and these are halogens. Now, cobalt, nickel, palladium, platinum, iridium are having different chemical properties. We should not incorporate like that. Elements having dissimilar chemical properties cannot be grouped together. It is the main limitation in Newland's law of octaves. Now, the Newland law of octaves is somewhat correct for higher elements like calcium. Now, elements whose weight is more than calcium, it cannot be applicable correctly, but the atomic weights of lower elements can be applicable very clearly in this Newland's law of octaves. Now, law of octaves is somewhat correctly applicable up to calcium, that means only elements up to here are applicable valid for this law, but it is not correctly applicable to the elements having more atomic weight than calcium. Now, you see here, now elements whose atomic weight is greater than calcium are, this law is not suitable. Now, he did not leave any space for new elements. Suppose if we want to add any new element in his periodic table, there was no space. Now, later on many more elements were discovered, to keep them there is no space in his periodic table. Now, you observe there is no place for any new element, that is why this periodic table is also failed to incorporate some later elements. Now, there are instances of 2 elements fitted in the same slot, again we will repeat. Now, we will study the limitations of Newland's law of octaves once again. There are instances of 2 elements fitted into same slot. Certain elements totally dissimilar in their properties were fitted into the same group. Newland arranged cobalt, nickel, palladium, platinum and iridium which have different properties compared with halogens in the same row, that is fluorine, chlorine, bromine and iodine. Now, law of octaves is somewhat correctly applicable up to calcium, but it is not correctly applicable to the elements having more atomic weight than calcium. Newland's periodic table is applicable for only 56 elements. Now, he did not give an extra space to add next generation elements. Now, that means in future any new element is discovered, there is no place to keep in his periodic table. Now, we will see what we have learnt in this session: atomic number, mass number, ฎ law of traits, Newland's law of octaves. Now, children, let us take small homework. Name the scientists who were involved in the classification of elements. Write the atomic number and atomic mass of different elements in the form of a table column. What relation about elements did Ḍ want to establish? Do you think that Newland's law of octaves is correct? Justify. Now, dear children, today we learnt about the evolution of periodic table and we have studied the Ḍ law of traits and Newland's law of octaves. Now, we will meet in the